अस्सलाम वालेकुम। ये नेक्स्ट आपका जो लेमा है दैट इज द Borel-Cantelli lemma and the statement is let EK be a countable collection of mutable sets for which uh, the sum of the measure of these sets is less than plus infinity. Then for all x belongs to R belongs to at most then for almost every, not for all. Then for almost all, not for all. Then for यहाँ पे आपके पास क्या होगा almost. Then for almost all x belongs to R belongs to at most finitely many of the EKs. Okay. So this is the Borel-Cantelli lemma. So अगर मैं इसकी statements देखूं, first of all given मुझे जो collections of sets हैं वो countable collection है and that are not relatively disjoint of mutable sets. ठीक है. Secondly, ये है कि the sum of the measure of EK, sum of the measure of this sequence of sets is less than plus infinity. So what does that mean? अगर it's a series, अगर आप देखें it's a series of numbers. So अगर कोई series जो है वो converge करती है, it's mean the nth term or it's a kth terms m of EK is approaches to 0. Okay, so for k is approaches to infinity. So what does that mean? It's mean के जैसे जैसे आपका sequence जो है वो move कर रहा है, जैसे ये E1 से E2 and E3, so it's going toward the infinity as well as k is approaches to infinity. The size of the sequence, because the measure of the set is the size of the set. So the size of the set is going to shrink. It's going to is approaches to 0. ठीक है? Such that the sum of the series is less than plus infinity. ठीक है? So it's a very big thing. ये अगर आप देखें इसी की वजह से आपकी जो है ये so this is the main given object to prove this Borel-Cantelli lemma. ठीक है? सो नॉर्मली अगर आपकी nth सीरीज जो है वो 0 को अप्रोच करती है तो इसका मतलब ये नहीं होता कि आपकी सीरीज जो होती है वो कन्वर्ज करती है, बट ये आपके पास क्या है कि सीरीज कन्वर्ज कर रही है. व्हाट डज दैट मीन? द साइज ऑफ द nth टर्म is going to shrink. Then for almost all x, so for almost all x mean almost everywhere for belongs to at most finitely many of these cases. So what does that mean? इसका मतलब ये है कि I have to prove that the measure of all those x belongs to R such that x belongs to En infinitely often for infinitely many n. Okay, so x belongs to En for infinitely many Ens. सो इस सेट का मेजर जो है इट शुड बी 0, क्योंकि वो सारे पॉइंट्स जो कि इनफाइनाइटली मैनी En से बिलोंग कर रहे हैं उसका मेजर 0 है. बिकॉज आई हैव टू प्रूव दैट फॉर ऑलमोस्ट ऑल मींस द आई मीन सेट्स का जो कॉम्प्लीमेंट होगा फॉर ऑलमोस्ट ऑल x बिलोंग्स टू R बिलोंग्स टू एट मोस्ट फाइनाइटली मैनी ऑफ द Ens. ठीक है? सो अगर मैं कोई भी x लूंगी तो इट्स बिलोंग्स टू द फाइनाइटली मैनी ऑफ En. सो आई हैव टू प्रूव दैट द मेजर ऑफ द सेट दैट बिलोंग्स टू इनफाइनाइटली मैनी ऑफ En मस्ट बी इक्वल टू 0. सो अगर आप इस चीज को गौर से देखें तो ये चीज क्या है, ये जो सेट है ये क्या है, ये आपका लिमिट सूप है. So that is the limit soup of k for ek. Yeah, n for ens. Okay. And so this is equal to 0. So what I need to prove that the measure of this set, the limit soup of ek is equal to 0. So this is my actually claim or target. So prove इसका जो है, so given मैं फिर statement repeat कर रही हूँ, let ek be the countable collection of mutable sets for which this conditions hold, right? Then for almost all x belongs to R belongs to at most finitely many of ek. So I hope कि आपको इसकी statement समझ आ गई होगी. So let's move to the proof. So for proof, first of all, so what I need to prove that the measure of the limit soup of this set is equal to 0, Lebesgue measure. So what is the limit soup of k ek? So by definition, this is equal to the intersection for n is equal to 1 to plus infinity, and the union for k is equal to n to plus infinity ek. Okay, so this is the intersection over union. Okay, so we suppose that this set, so sorry, suppose that this set is fn. So let कर लेते हैं कि fn जो है वो आपका क्या है, that is equal to the union for k is equal to n to plus infinity ek. So it's again a sequence of sets for n is greater than n equal to 1. So it's again a sequence of sets. Then your limit sup of k ek is exactly equal to the intersection of n is equal to 1 to plus infinity fn. Okay, let's see this sequence, how this sequence behaves. So first of all, it's a decreasing sequence. Definitely f1 is the superset of f2, f2 is the superset of f3, f3 is the superset of f4, and so on. Why? Because f1 is the union from k is equal to 1 to plus infinity, f2 is the union from k is equal to 2 to plus infinity, so f3 is from 3 to plus infinity. So जैसे जैसे आप मूव कर रहे हैं तो कलेक्शन जो है वो स्मॉलर होती जा रही है. सो f1 is the supersets among all this sequence. So and the measure of f1 is equal to the measure of the Lebesgue measure of union for k is equal to 1 to plus infinity ek, and this is less than equal to by using the countability subadditivity. So I will write here by using the countability subadditivity. So by using the countability subadditivity, I can say that this is less than equal to summation k is greater than and equal to 1 or k is equal to 1 to plus infinity measure of e. And given that this series is convergent, so this is less than plus infinity. So this implies measure of f1, the Lebesgue measure of f1 is less than plus infinity. So what does that mean? The first condition, that it's a decreasing sequence, and the Lebesgue measure of the largest set is less than plus infinity. So I can apply the continuity of measure from above. Okay, so so using the continuity of measure, from above, so you will get that the limit for n is approaches to plus infinity, measure of fn exactly equal to the measure of intersection for n is equal to 1 to plus infinity fn. अब ये जो चीज है आपकी, ये अगर आप देखें यहाँ से तो इंटरसेक्शन ऑफ एफ एन क्या है आपका, लिमिट सूप ऑफ ई के. ठीक है, सो दिस इज एग्जैक्टली इक्वल टू द मेजर ऑफ द लिमिट सूप ऑफ के ई के. सो no, so here you have your equation 1. Now let's see how what is the limit of this sequence. So measure of fn is equal to the measure of what is fn, that is union for k is equal to n to plus infinity. Okay, ek, so that is less than and equal to this is less than equal to, by using again the countability subadditivity, so k is equal to n to plus infinity measure of ek. And what is the value of this this, if you see, this is the error of the sequence of partial sums. So let's see, so for n is approaches to infinity, this number is approaches to 0. How? So for n is approaches to plus infinity implies a limit Meyer of Fn and n is approaches to plus infinity is less than n equal to the limit of n is approaches to plus infinity summation k is equal to n to plus infinity Meyer of Ek, and that is exactly equal to 0. Why? Because if you see, okay, let me explain. It's just a series. If you see given that the series summation k is greater than or equal to 1, m of Ek is less than plus infinity. So if you see the sequence of partial sum of this, say Sn is exactly equal to, if you take this is S, so the sequence of the partial sum is k from 1 to n, Meyer of Ek, right? So as your Sn is converges to S for n is approaches to infinity. So you can see that the Sn minus S that is approaches to 0 as your n is approaches to infinity. So what does that mean? It's mean that Sn minus S is exactly equal to the summation k is equal to n plus 1 to plus infinity Meyer of Ek is approaches to 0 as n is approaches to infinity, because ये आपका क्या है, infinite sum में से आप first n terms को subtract कर रहे हैं, ठीक है? So this is exactly equal to error of the series. So and this is equal to 0. So ये just ये green में आपकी just explanation है, और ये just series की basic notions हैं और कुछ भी नहीं है. So this is equal to 0 and from 1 so let's see from 1 the Meyer of the limit sup of n sup of k Ek is equal to the limit n Meyer of Fn that is exactly equal to 0. और ये लेस देन का साइन था बिकॉज आपको पता है कि 0 इज ऑलवेज लेस देन इक्वल टू द मेजर ऑफ एनी सेट्स, ठीक है? सो इसलिए 0 की okay, so by sandwich theorem this is equal to 0. So this is what we need to prove. So the measure of the limit of the sequence of partial sum measure of the limit sup of Ek is equal to 0, and that is what we need to prove. Okay, thank you.